Stop. Sign convention is the biggest reason why students lose marks in mirror and lens questions. In the next 8 minutes, I will make mirrors, lens, magnification, and sign convention super easy for you that you are not going to lose marks ever again. So watch this video till end.
In this video, we are going to study in detail about mirror formula, lens formula, magnification, and sign convention. The first part which we are going to discuss about is the mirror formula. The mirror formula defines the relationship between object distance. Now, what is this object distance? We know that the mirror which curve inwards is known as concave mirror. So the distance of object from P, if my object is over here, here it will be F and this will be C. If my object is in between C and F, so the distance from pole till this position will be U. So we can say that it's the object distance from pole to a certain point. Now the image, suppose the image is forming here. The image is forming here. So the image distance from the pole, this entire distance will be considered as image distance. So the distance of image from pole will be considered as image distance. What is focal length? Focal length is the distance between P and F. This distance from P to F will be focal length. And we already know that F is equal to R by 2. What is R? The distance from P till C. This shows the radius of the imaginary sphere and which is known as radius of curvature. The focal length is half of this distance from P to C. Therefore, we can write F is equal to R by 2. Now, mirror formula give you a relationship between the image distance, object distance and the focal length. And it can be written as 1 by F is equal to 1 by V plus 1 by U. And it is applicable for all spherical mirrors under all conditions. If an object is placed 10 centimeter from a convex mirror of radius of curvature 60 centimeter, then find the position of the image. So what are the given quantities over here? The given quantities, object is at 10 centimeter. So यहाँ मैं u ले लेती हूँ, u कितना हो गया? Minus 10 centimeter. Radius of curvature capital R is 60 centimeter. What will be the value of f then? R by 2 is equal to 60 by 2 is equal to 30 centimeter. We have to find the value of V. Formula for mirror formula is equal to 1 by F is equal to 1 by V plus 1 by U. We already have a value of U and F. So 1 by V is equal to 1 by F minus 1 by U. Now here U is taken as negative. Why U is taken as negative? If you see the sign convention, this is the 2D coordinate plane, right? 2D Cartesian plane. You have x, x dash, y and y dash. Here you have all positive values and here you have all negative values. Now for a convex mirror, if I say convex mirror, so let's make this mirror like this. For a convex mirror, the position of object can be either at infinity or at some finite distance. My object can be here, or it can be at infinity position. Now you can see that it is present on negative x-axis. That is why the sign for object distance will be taken as negative in both convex and concave mirror. So 1 by V is equal to 1 by F minus 1 by U is equal to the value of F is 30, 1 by 30 minus 1 upon minus 10 is equal to 1 upon 30 plus 1 upon 10. Now if you take the LCM, it will become 30, 1 plus 3 is equal to 4 upon 30. When you solve this, you will get the value of V as 7.5 centimeter and this is your answer. Magnification, it expresses the relative size of image as compared to the object, that how much my image is magnified or how much my image is diminished as compared to the object. The formula for magnification for spherical mirrors is, for spherical mirrors is m is equal to hi by, you can also write it as hi by ho or h dash by h, where hi is what? Hi is height of image, height of image divided by height of object, height of object. So this is one formula by which you can find the value of magnification, that how much of your image is magnified or how much of your image is diminished as compared to the size of the object. Magnification is also related with the image distance and object distance. In this formula, the u is representing, your v is representing image distance and u is representing object distance. So magnification can also be written as minus v upon u. This is another formula for magnification. The image distance and object distance need to be always taken with the appropriate signs. So if m is negative, the value which you get after calculating for m, if it is negative, your image will be real and inverted. As in the Cartesian plane, if you see the image in the case of concave mirror, most of the images are formed in this direction, right? And as it moves away, it's become what? It increased in size. So the image which is formed below the axis, here you will find the value of m as negative and the image will be what? Real and inverted. If the value of m is positive, then image will be virtual and erect. Let's do a question based on the magnification of spherical mirrors. An object is placed at a distance of 12 centimeter. So here u will be minus 12. It forms a real image 4 times larger. So magnification given is 4 times, but along with that it is real image. Magnification will come in negative minus 4. Calculate the distance of image from the mirror. You have to find the value of v. M is equal to minus v upon u. Put the values. Minus 4 is equal to minus v by minus 12. Minus v will be equal to 48. So v is equal to minus 48 centimeter. This is your answer. Let's move on to the next part, that is lens formula. What this lens formula tells, or it gives you the relationship again between focal length, image distance and object distance. We already know u is object distance, v is image distance and f is focal length. To calculate, it helps you to calculate the exact position of image, and then again the lens formula is applicable for all spherical lenses in all conditions. This is very important. Now let's do a question quickly based on lens formula. An object is placed 25 centimeter in front of a concave lens of focal length 25 centimeter. So what values are given to you? U is equal to minus 25 centimeter and f is equal to minus 25 centimeter. Why this negative sign is there? Because we know that the distance object, if there are two cases for the concave lens. One is at infinity, if the object is at infinity, or if the object is at finite distance. So in both the conditions, the object will be placed on this side. And we know this is the positive x-axis. This is the negative x-axis. Okay, so because of that, the sign for u and f will be negative. And we know that the image is also going to form on the same side of the object in the case of concave lens. That is why u and f will be negative. And you have to find the image distance. So apply the formula 1 by v minus 1 by u is equal to 1 by f. Or 1 by v is equal to 1 by f plus 1 by u is equal to 1 upon minus 25 plus 1 upon minus 25. Or it can be written as minus 25. It will become 1 upon minus 25 plus 1 upon minus 25. That will be equal to 2 upon minus 25 is equal to 1 by v. The value of v will be equal to minus 25 upon 2. That is equal to minus 1 to 12.5 centimeters. And this is your answer. For spherical lenses, the formula for magnification differs a little from that of the mirrors. Here the value of m is equal to image height by object height, which is equal to v upon u. Here we don't have any negative sign. Now here comes the most important part where most of the students lose their marks because of the wrong sign. So understand this very nicely. This is the new Cartesian sign convention for spherical mirrors and lenses. So this is a common flow diagram which you can use to understand and to memorize. Now see here, this is the mirror, right? This is the concave mirror. Now all distances, the first rule is that all distances are going to measure from pole. Distances will always be measured from pole. Distances will be measured from pole. And all distances towards right will be taken as positive, whereas all distances measured towards left will be taken as negative. So in the case of concave mirror, your object distance will be taken as negative, as the object is on this side, on always the negative side of the x-axis. So you will always be taken as negative. In the case of convex mirror, if you see in the case of convex mirror, then also the placement of your object is either at infinity or at the finite distance. Then also the u will be negative. That means u will be negative for both the mirrors, for concave as well as convex. Now let's talk about focal length. Here is the P. This point let's consider focus, and here we consider center of curvature. So in all the cases, the distance between P and F will be considered as the focal length, and this is on the negative side of the x-axis. So for the concave mirrors, the focal length will be taken as positive, whereas in the case of convex mirror, the image is always going to form on the same side, both the images are going to form on the positive side of the x-axis. So f will be taken as positive. For concave mirror and convex mirror, both the mirrors we have seen that object distance will always be taken as the negative. It will always be taken as negative. Whereas the focal length in the case of concave mirror will be taken as negative, as it is present on the negative x-axis, whereas the focal length in the case of convex mirror will be taken as positive, as the image is going to form on the positive x-axis always. So in the case of concave mirror, convex mirror, the F will be taken as positive. So this is the sign convention which you need to do as per the concept in most of the numericals. And if you put the wrong sign, the entire question goes wrong. So these are the three important points, that distances will always be measured from the pole. The object distance will be negative for both concave and convex mirror. For the focal length will be negative for concave mirror. Now you know the reason why. And the focal length will be positive for the convex mirror. In the case of spherical lenses, again, the object distance, the distances measured towards right will be taken as negative, and the distances measured towards left will be taken as positive. One important thing which you can remember is that if you have learned the sign conventions for the spherical mirror, then the same goes with the lenses also exactly. So you will be negative for both the lenses, and for focal length for concave lens will be negative, and focal length for convex lens will be positive. So exactly the sign convention of mirror is applicable for the lenses. We don't have to think directly. Whatever concept is there for mirrors, that you can apply for the lenses. Then one important thing is that if the height is up towards upward, above the principal axis, we take it as positive, and if the height is downward, we take it as negative. So that also we need to take care of. Suppose a real inverted image is formed, real inverted image is forming, and the magnification to you is given 4. So what numerical value and sign you are going to use in the question? -4, because it is real and inverted. That means below the axis. And so if the image is forming above the axis, we will take H as positive, and if the image is forming below the axis, then we take it as negative. Or you can say that which virtual images it always goes positive, and with the real and inverted images it goes negative. Diagram, you can understand that where is exactly the focal length in case of convex lens and case of concave lens. Convex lens, as you know, that it's a converging lens, and the image is always going to form on the positive side, always on the positive side of the x-axis, and therefore this is the distance between the lens and the focus for this particular lens. So this portion will tell you the focal length. Then concave, the case of concave lens, as you know that the image forms always on the similar side of the object, and that is why the distance from the lens to the focal plane, or you can say the distance from the optical center to the focal plane will be considered as a focal length. Let's just go through quickly the golden rules for numericals. Incident light always travel from left to right. It's always going to travel from left to right in this direction always, because the placement of object will always be on the negative side of the x-axis. All distances are measured from pole or the optical center. In the case of mirror, the distances are measured from pole, whereas in the case of lens, the distances are measured from optical center. Distances to the right of origin are positive, and distances to the left of origin are negative. All distances on this side will be negative, and on this side will be positive. Vertical y-axis, the height above the principal axis will be positive, so this will be taken as positive, and this will be taken as negative. I hope it's clear. Now, how to interpret the magnification value? If m is equal to +2 or m is equal to -3, image is larger than the object. If m is equal to +1 or m is equal to -1, the plus and minus is just showing that whether the image is forming above the principal axis or below the principal axis. But the numerical value is showing that how much the size of image is increased with respect to the size of the object. If m is equal to +0.5 or m is equal to -0.3, then the image is smaller than the object. So you can take these three values, and you can learn these three values. And whenever the value is 1, then the image size is always equal to the object size. If the size of the image is less than 1, less than 1, then the image will always be smaller than the object. And if the value of m is more than 1, I'm just talking about the values right now, okay? So then in that case, the image will be larger than the object. And what this plus and minus sign is showing, just the image is forming above the principal axis. When it is forming above the principal axis, it becomes positive. And when it forms below the principal axis, when it is forming below the principal axis like this, it becomes negative. As you can see in this tile, that plus m object, the nature of the image, it just show the nature of the image, it becomes virtual and erect. And the negative sign shows that the object is erect, you can see, but the image is what? Real image and inverted image. I have already uploaded these flow diagrams on my channel. You can refer them from time to time. I hope you all liked the video. If you could understand well and liked my mind mapping and flow diagrams, and it is easy for you to understand, please like, share and subscribe my channel for more such videos.